In this APCS video, we're going to be going over a concept known as recursion. Now, recursion is only, as of 2022, is only going to pop up in the MCQ portion of the exam, not the FRQ. So, expect to see recursion only in the MCQ part. You won't be asked to write any recursive methods in the FRQ section as of 2022. So recursion can be sort of a tricky concept at first. Hopefully by now you know how to write methods and call them. That's going to be really important for this concept. So let's start by creating let's write some pseudocode so that we can sort of understand what exactly recursion is, and then towards the end of the video I'll do about 3 practice problems and we can go over them together, and then in the description I'll link a full there'll be a link with a lot of practice problems so that you can get comfortable with the recursion. So let's say I have a method here, public static, and then I'll just say public static int, and let's say it takes in one parameter, and that's like int b. So I have my method here, and if you wanted to normally call this method, what you would probably do is to call it, you would do something like, let's name this method, let's just name this method A. So to call it, you would do something like A, and then in parentheses you'd have your one parameter, which is an int, and it's b. So you do like A6 or A5, and that would essentially run whatever code is over here. But in recursion, the method will actually call itself inside of the method itself, if that makes sense. So let me just give you an example. So instead of, let's say this was our main method over here, instead of calling A over there, what might happen is it might do something like, inside of the method it might go like return A7. Now, as you can see, we're inside of method A, but method A is calling itself, and that's what recursion is. And we'll get into some other vocabulary like what a base case is and what infinite recursion is. But for now, I think you should just you should be comfortable with the fact that this method A is calling itself. So whenever A something is called, it's actually going to, in this case, it's going to return the result of A7. And in order to solve these MCQ questions, we're going to use something called hand tracing, which is one of the better strategies to use when solving recursion questions. And essentially, this method could technically go on and on forever, because you're going to just keep calling A over and over here without any sort of stopping. Because once the method runs once, it's going to call A7, and then A7 is going to be called, and then A7 will be called again and again and again. So what's going to stop that method from going on again and again and again, which is something called infinite recursion, when the method won't stop, it'll just keep calling itself over and over and over. The thing that stops that is actually called a base case. So now that we have all this vocabulary here, I'll be using some of this vocabulary when we do the practice problems, but it's good to know these words. So just as a quick review, hand tracing is a strategy to solve recursion questions, and then infinite recursion is when the recursive method. So a recursive method would be a method that we are using recursion in. For example, this A method is recursive because the method is called A and it's calling itself right here. So that would be infinite recursion if the method just never stops calling itself. It will just go on and on forever. And the base case is what's going to stop this infinite recursion from happening. So the base case could say, if something here is true, then let's return maybe 0 instead of this method being called again. So the base case is going to stop infinite recursion from happening. And I'll use these vocab words while we're doing the questions so you can sort of see them in an actual problem that you might see on the AP exam. MCQ problem, and take a minute to pause the video and see if you can do it yourself. Okay, so hopefully you gave it a shot and maybe you even got an answer, your answer, but I'm gonna go over it nonetheless. So as you can see, we have this mystery method which is returning an int, and remember how I talked about what our base case is? Well, in this case, when n equals 0, that's going to be our base case, because that is gonna be what stops this recursive method from running over and over and over. It's going to stop it from running, infinitely. It's going to stop the infinite recursion. So this n equals 0 right here, that's our base case. So now let's take a look at this problem. So it's saying, given the following method declaration, what value is returned as a result of the call mystery 5? So what we're starting with, and I'm just going to abbreviate by writing MYS, is we're starting with mystery 5. So over here, I'm going to do the method that we know as hand tracing. And essentially what hand tracing is that you write out the call of the method. So in this case it would be mystery 5. Then you write an arrow and you would write the result. So basically when we do mystery 5, n will be 5 and n is not equal to 0. So it's going to go to, over here to this else condition right there. So it's going to go to that else condition. And we know that mystery 5 will return us 3 times mystery and then n minus 1. So it will be mystery 4. So now that we are at mystery 4 over here, we're going to start with mystery 4 on our left side of the hand tracing. So we're going to go mystery 4, and then that's going to become, well, let's see, so 3, so it's going to be 3 times mystery, and then n minus 1, so n is 4 in this case, so we're going to do 3 times mystery 3. And we're going to keep doing this until we get to our base case. So it's going to be, next up we're going to have, as you can see, mystery 3 is over here now. So we're going to go mystery 3, and then that's going to become 3 times mystery n minus 1. So n minus 1 over here is going to be 2, because 2 minus 1, because 3 minus 1 is 2. So now we have mystery 2. So we're going to do mystery 2, and then that becomes 3, so that's going to be 3 times mystery, so 2 minus 1, so it's going to be mystery 1. So each time you're going through this hand tracing method, you want to make sure that what you're writing on this right side won't, you want to make sure, you want to keep checking if it's going to satisfy this if condition, which is the base case, like I said, because in that case, it will return 1 instead of 3 times mystery something. So we're going to keep going because we're currently at mystery 1, and 1 does not yet satisfy that. So mystery 1, and then that will become, so mystery 1, if you plug it in, n is currently 1 does not equal 0, so we're going to go 3 times mystery, and then 1 minus 1 is 0. Okay, so we got to mystery 0 now. That is our base case, because this 0 right here, this right here is n, and n is now 0. So now we can say, okay, so mystery 0, when I call mystery 0, what is returned? Well, when n is 0, we see this if condition right there, it's going to return 1. So we can essentially replace this mystery 0, we can just say that's 1. So now that we know that, this is where hand tracing is really useful. We know that mystery 1 is 3 times 1, so we know that this is 3. So we know mystery 1 is 3, so then this is going to become 3. So now we know 3 times 3, mystery 2 is 9. And now that we know mystery 2 is 9, this is going to become 9. So 3 times 9 is 27. So now we're going to keep just going through our hand tracing. So mystery 3 is 27, so that's 27. So 3 times 27, that's going to give us 81. So now we know mystery 4 right here is equal to 81. So now we can replace this with 81, and we know that 3 times 81 is equal to 243. So now that we know that mystery 5 is 243, we look at our options. Okay, the answer is A. So I think the important thing to note here is that you really want to sort of write out and show your work, because doing something like this in your head, it can get really tricky and it's pretty easy to make a mistake. So I think the strategy you should go with for these problems is using hand tracing, and really being thorough about writing everything out so that you can avoid silly mistakes on MCQ questions like this. Now here's another MCQ question, and it's essentially saying select the line or lines. So select the line or select the line or lines that contain the base case, contain the test for the base case. So remember, what we define as the base case is essentially what will stop. So it'll stop the recursion from going on and on and on. So it's going to stop the infinite recursion. So here we can see that we have the method factorial, and it's taking an int. And here in this else statement right here is where we are calling our, right there is where we're calling the factorial method within the factorial method. So this is the recursion part of the code, because it's calling the factorial method. Now, if our base case is what stops this factorial method from calling itself over and over and over, then we can probably assume that if we're returning 1, that's not, and 1 is not, 1 isn't going to be, 1 isn't going to, it's going to stop the infinite recursion. So if I'm returning 1, I'm not returning n times factorial n minus 1. I'm not calling the method. So we can say that our base case, so what has to happen for 1 to be returned? Well, that means that n has to be 0. So we can say that this line right here is our base case, because we know that when n is 0, the method is going to stop calling itself. It's just going to return 1. So therefore the answer is, this would be line 3. That is the answer. So this is going to be the last practice problem that we do in this video, but if you want more practice like this, I'll be linking a website in the description that will have a lot more practice problems like this. So again, here we have another mystery method, so int mystery, and it's taking in one parameter, int n. So like we did in the last video, we can identify our base case here. So again, when n is equal to 0, we know that our recursion is going to stop. So I'm going to use, again for this problem, the method that I recommend that you all use, and that is hand tracing. So it's asking us, given the method defined below, what does the following return? And it's asking, what does mystery 5 return? So I'm going to write out on the left side what we're calling, so mystery 5. And mystery 5 is going to call, so n is equal to 5 in this case, and n is not 0. So that means that we're going to be going to this block of code over here, this else condition. So now, so that means that we're going to do 2 times the mystery method, and its parameter is going to be n minus 1. So n is 5, so n minus 1 is 4. So now we're at mystery 4. Mystery 4, and then 2 times mystery 3. And we're just going to keep going through our hand tracing. So mystery 3 is 2 times mystery 2. And remember, we're checking to see if we've met our base cases yet, which we haven't, and is not equal to 0 yet. So we're going to keep going. So mystery 2 goes to 2 times mystery 1. So we haven't met our base case yet. So mystery 1 goes to 2 times mystery 0. Okay, n is equal to 0. So right here, n is equal to 0. So we've met our base case, because remember how we said our base case is when n equals 0, we're going to return 1. So like the first problem, we know that when we call mystery 0, that's going to be equal to 1. So we're going to replace this with a 1. So then we know that mystery 1, when we call it, it's going to return 2. So if mystery 1 is 2, then over here we can replace mystery 1 with 2. So then mystery 2 becomes 4. And now that we know that mystery 2 is 4, we can replace it over here. So 2 times 4 will be 8. So we know mystery 3 is 8. And so then 2 times 8, so mystery 4 will be equal to 16. And then we know that mystery 4 is 16, so we can cross that out and we can make this 16. And then 2 times 16, we know that this will be 32. And from these options here, we can see that our answer will be B. So hopefully this video helped you out in sort of an introduction to recursion. Thanks for watching.